Good afternoon, everyone. Welcome to our first webinar for CESA Technology Engineering Innovation Forum. Today's program will be tackled by me as a facilitator, and I have three wonderful speakers who will be taking us through. Fellow members and guests, good day. CESA, which is Consulting Engineers South Africa, is a voluntary association with over 580 companies, both locally owned and also companies which are owned and multinationals. It's been in existence for over 70 years, and it has placed itself as a market leader or in the industry by supporting member firms and governments in executing projects. It has a field of over 19,000 people, which it has touched through mechanical, electrical, structural, and industrial engineering. CESA has various committees where it assists companies or member firms in beginning the conversation around best practice. Today, under the umbrella of technology, engineering, and innovation, we bring this particular webinar. The forum was created in 2019, and it sits under CESA's Transformation Development Committee, chaired by Jabulile Mnisa. The forum creates ideas platform and a free space for members to share knowledge, formulate new innovation and solutions within the industry. Also, the forum is meant to be a go-to organization to help address technology in the industry and in our spaces. With that, the theme of the webinar is digitalization in the construction industry. The industry has accelerated the adoption of technology, and I push this to COVID-19. The adoption of the technology was brought on by employees working from home instead of the office. Projects needed to continue, thus the sector needed to acquire the latest technology and would be used to collaborate amongst clients, professional team, and contractors. With South Africa and its economy struggling at the moment, technology is going to play a critical role in this implementation and enhancing project execution. We want every rand value for the project. We consider the use of digital delivery system as a critical industry market leader. One may ask, what is this digital project delivery? It is a way of working where the project from conception, planning, design, build, operate in a digital space for all stakeholders. This approach relies on the use of a common data environment to support multiple discipline and multiple collaboration and design management, as defined by Autodesk. If you would allow me, I would like just to share one screen. Right. Fortunately, technology is overpowering me and I'm leading the technology group. But if I move forward, we have 3 speakers. The first one will be Tato. We will then have Keith, and then we'll have Steve. We have 3 amazing speakers with wealth of knowledge in our space. And we are so privileged to have them speaking to us. Let me give you just a brief on who Tato is. She's a project engineer from PSW, Consulting Engineers. I asked her a simple question. What excites you outside of engineering? And she responded with 2 things: serving and then volunteering. It's such an important thing to think about. As we try and grow this particular platform and how we need to execute projects better, the more volunteers, the more people out there, the more it's easier for other member firms to learn about new technology. With that, she has qualifications in electrical engineering, computer engineering from UP. And her topic is computer vision for smart site inspection or monitoring, opportunity and challenges. Tato, it's over to you.
Thank you so much, Sikulile. Thank you for the introduction, Sikulile, and good afternoon, everyone. Thank you to CESA for having me on this webinar, and to the panelists, Keith and Steve, and of course to you for joining us today. I am Tato Law, and as Sikulile has introduced me, I have an honors in computer engineering from the University of Pretoria. I then transitioned into electrical engineering with ESCOM when I was in engineering training through my bursary obligations. And I've since been with PSW, where I have been a project engineer for close to 8 years now. As a project engineer, our scope of service is from stage 1 to 6 from the CESA guideline, with site handover commencing in stage 5. So now, digitization in construction is very broad and multifaceted. So my topic, computer vision for smart site inspections or monitoring, opportunities and challenges, is going to be restricted to the areas of safety management, progress monitoring, productivity tracking, and quality control in the construction stage. So I won't be covering BIM or Revit or similar building design tools. In the framework of my topic, I will take you through my pain point reflections and the current status we're on in construction monitoring. I will do my best to show you a glimpse of possibilities with computer vision technology, how it works and is applied in construction, what are the limitations and opportunities it presents. Now, think for a moment, how many photos have you taken from construction projects during construction? I have taken a lot of them. And somehow, even with the advancement of technology and the increasing use of camera-equipped devices such as your phone, your tablet, drones, and robots, the number of photos and videos we collect is still rising. And so now in this vast information collection of the images, there is valuable data that when properly captured and reported on, can give insight into project management activities such as audits, quality inspections, safety management, and resource utilization with surveillance. Now, when you're working with photos, the worst thing you can get from your phone is that your memory is full. And now, having collected these photos, the hard work begins of now collating these photos from your phone, transferring them and taking them into something meaningful information through your defects, your inspection, or even your due diligence reports. This is now where, for me, it's the most painful, effortful, and time-consuming side of this activity. Because, first of all, you had to remember, where exactly did I take this photo? What was the photo about? How big was the impact? What was the impact of this defect? If you had taken dimensions or measurements on site, how big were they? So you need to refer to your notes. And also battling sometimes for formatting in Excel. And so it is at this point where I would like literally have to take a deep breath, you know, to begin tackling this work. However, now I do take a breath of relief because of the advancement of apps that have been made available with technology recently. And you find apps like SiteWorks, SnagR, or AuditBricks and SnagBricks. And so with these apps, you're able to monitor your defects, your observations, your snags, your inspections, your issues and items. And the beautiful thing about it is now you can actually see it on your building layout plan, on where exactly this snag or audit has been taken. And you can now assign it to the responsible person for action. And you can generate like beautiful reports, like professionally formatted, of course, with your organization details, and then you can send to the relevant stakeholder. Yes, it is still some human effort is still there, in which we still need to extract and describe the issue or defect or snag or the evidence from the picture taken. Yes, it's still our responsibility as engineers. And so the automation of extracting information from images and videos requires the development of technology that would enable a computer to understand an image by detecting, identifying, and classifying the object on the image. So it works similar to how our own human vision systems work. Computer vision is a multidisciplinary AI field that derives meaningful data from pictures, videos, and any visual input like some cameras or sensors. It requires algorithms and technologies to enable computers to understand digital images or videos which mimic or replicate the functionality of the human visual system. And so if you're using it efficiently, you can automate construction management activities by using machine learning to teach computers to see defects and issues before they can affect operations. So this is just a brief, very, very high level view of what happens in computer vision, where an image is acquired and it gets taken through what we call a data pre-processing. This is what is called cleaning up the data to prepare it for the training phase, where in this phase, more image processing gets taken place through your deep learning languages or your neural nets, where then an optimized algorithm is then used to give you meaningful inferences on the images that it's now being it's engaging with. So these inferences are they able to do? It's able to classify images, that is by accurately predicting what class is this image. So for example, like if it's a dog or if it's a person or a big hole in cement, I don't know. And also through object detection, which uses image classification to identify a certain class of image and then detect and tabulate the appearance in the video or the image. And then, of course, object tracking, which tracks an object once it has been detected. And this usually works with when you're executing images or motion, a sequence of images, or real-time video feeds. The computer vision can be achieved with various types of cameras. You've got your RGBD camera, your 3D depth camera, your depth camera, or your stereo camera. Most phones have 3D depth. If you have an iPhone, you have depth and LiDAR. So some of these phones that are available now, you can use that camera and perhaps maybe use Matterport to create what we call now like a digital twin. Of course, this is in small scale. You need a very, big cameras sometimes, but the nicest thing with digital twins that can help with the problem that it can help with in construction. It's, for example, if you're taking on a refurbishment project and layouts are lost, if you have a digital representation of the physical assets or building, it can really help to know what is as built, as it were, and what is available for investigation, for example. And also your assets, what inventory of assets are there in your physical structures as well. And then using them on drones, or what you call like unmanned aerial vehicles. This you can use for tracking surveillances, progress timelines, resource utilization, and safety management. Also, if you want to map an area as well. And with virtual reality or augmented reality glasses, or wearables as they call it, the nicest thing is on you. You can use it to analyze the environment, to detect site monitoring. Perhaps you're not the professional, and you're there and you need your manager to see what you're doing or the defects that you see, or even measuring distances with the augmentation of sensors. And of course, robot sensing, which it's basically helping the robot, giving it the ability to see through the cameras and accessing remote areas where it may not be safe. This is when in the initial part, perhaps, of the project, for humans to go to that site to analyze the environment. And also to make computer vision more efficient, the use of sensors is utilized. Like you have your thermal imaging, which can be used to detect hotspots, maybe on distribution lines. And the nicest thing about it, it can be used at night because of the night vision capability. And of course, your LiDAR, ultrasonic, radar sensors for detecting distance. Of course, they use different types of frequencies. The challenges, of course, are there in computer vision. First of all, yes, it is expensive, especially the use of sensors. I don't know if you follow Tesla, which computer vision is being used there in the automation industry a lot. They brought out a statement that said, no, we want to do away with the radar, and we want to purely use computer vision, which they call Tesla vision, and being processed with the AI. And so this gets very expensive when you're incorporating sensors. So if you can just use purely computer vision, then you're better off. But of course, there are concerns. And of course, lighting conditions. With cameras, you need good lighting. In exclusion of thermal imaging, which can work with night vision. And as you can see, the middle stage on the charts that I showed you on how computer vision works, the training stage needs a lot of processing power to be able to compute and go through multiple images. And I mean, when you take a photo, you can imagine, you know, it's a chunk of a size file, hopefully reduced when you've pre-processed it, but it requires a lot of computational power to be able to run through thousands of images so that you're able to get a more accurate and reliable prediction. And of course, there is the regulations on drones. You can't just use them anywhere. You know, there are limitations that the South African National, Aviation Authority has developed a list of those regulations, where you can go and where you can't do, how high, what's the range you can do, working with drones. And of course, adoption. Adoption in this case, as I've explained, like if you just put a camera there on your site and you're doing like a defects detection, I think for an engineer, you still want if you need to adopt this technology, you'd have to be satisfied with the outcome that this drone is now, that this AI is now going to suggest. So it still needs to be, integrated in gently and trusted for it to be fully adopted. And the opportunities are so vast. I mean, like if you have this computer vision with this AI training and having this much data and knowledge, you're able to make informed decision making. You can reduce your errors and project costs and your time on projects, because what you have collected on the construction stage, all that lessons learned from your drone, from the AI learning the site, you're able to use on another project in stage one. And and that just helps with your productivity and also time costs. You can get like safer sites with real-time feedback, and also high quality installation on sites with the feedback that you get from the construction stage data. And of course, the nicest thing that I've actually encountered in COVID was remote site inspections and monitoring. I was involved in a project where the client was in India and he was in the site inspection, and they were using a Matterport to show him the site and where the progress was, and the defects and the whole monitoring report. So this was very beautiful to see, and this was what amazed me on what are the possibilities that we can have in computer vision. Thank you.
Wow, that is awesome, Tato. I must say, I learned a lot, especially when you're talking about computer vision. It's the first time I'm hearing about it, and this platform is here for that. It's here to say this is what is coming in the industry, and therefore be aware as member firms and also as the industry. One thing that you mentioned, which I really like, is we as engineers, we get projects where we have to do site inspection, and you get there and your phone is full because you've taken so many pictures from one side to the next side to the next side, and you end up so confused when you're sitting in front of your desk and you are trying to process them. So by using this computer vision, you're saying that, look, here's a new way of doing things faster, better, and therefore it improves the quality of your project. Not only that, you also mentioned that cost savings for the client and for you as also the engineer, because there's also savings. Instead of going to site over and over, you reduce that as well. May I please then ask, before I go to the second speaker, I saw that I missed that one out, is that questions will be entertained. May I ask that there's a chat box, if you could maybe type those questions so that when it comes to our question and answer session, we will then be able to address that. So there's a chat box where you can type in all your questions, or question and answer, and then there's a normal general chat as well. Without further ado, thank you so much, Tato. We will wait for the questions. Keith is our next speaker, and he's a senior electrical engineer and energy manager from Deloitte International. When I was speaking to Keith as well, wow, I said to him, what excites him? And he thought about it quite long, and he said, I like watching old movies. Then when he started saying old movies in the 90s, then I thought, sure, what does that mean about me? Because those movies that he was referring to, I was watching them as well at that time. So which clearly means that I'm a little bit old. Criminal Minds comes to light. So that's the type of information and the type of things that Keith likes. Just a brief on Keith. He's got a very long resume. If I were to read it, it will probably give me another 10 minutes and we'll be then out of time. Because I'm time conscious, Keith, I will just ask you just to give us a brief on who you are, and then you do the presentation. Thank you so much.
Okay, cool. Thanks, Skulile, and yeah, special thanks to CESA for inviting me. It's always great to come back and do this type of events. My name is Keith Kachkora. I work with Deloitte US as their transmission grid and energy advisor. We're currently the implementing company for the US government Southern Africa Energy Program, where I was previously the Outcome 3 deputy lead for regional harmonization and integration. So basically all of your transmission interconnectors in Southern Africa. Through the program, our main mandate for the past 5-6 years have been focused at unlocking over 2,500 megawatts of new transmission capacity, enabling access to over 2 million households in Southern Africa, and then also advising on a number of energy-related policies in the region. We're currently doing our closeout now in preparation for the follow-on program, which the US government will announce probably end of this year. Moving right along, I will be speaking about technology and engineering innovation in local infrastructure development. And I think part of my presentation will also bring in some of the key observations and learnings through the work that we've been doing, not only in South Africa, but also the rest of the region and abroad. So yeah, the aim of my side of the presentation, a bit different from what Tato has said, is kind of highlighting where and how technology and innovation would fit in within the local infrastructure development for South Africa, because I understand a lot of you are within that space as consulting engineers. Highlighting obviously the importance of local infrastructure development, where it fits in, identifying some of the current challenges, which you would actually realize that they're quite cross-cutting with the rest of the other countries in terms of what's happening. And then also appreciate sort of the role of technology and innovation within local infrastructure development. And why this is relevant. I remember discussing an old World Bank report, I think it was a 2020 World Bank report, which spoke about how South Africa spends on average 2.25 billion rands per day on infrastructure development. And this obviously would be divided across energy, transport, ICT, and many other industries. And then in that conversation I was having with the group, we ended up saying, okay, so of that 2.5 billion rands per day, how much of that actually goes to the consulting engineering companies? And is it then enough for a lot of these consulting engineering companies to be able to get into a space where they can take the lead in terms of developing new innovations and new technologies that would be able to be useful in the future? And most of the time, obviously, the answer is always a resounding no, because if you look at the actual consulting fees that are taken within some of these projects, the percentages are quite lower, but that becomes a discussion for another day. And why local infrastructure then matters is that I think it's a foundation of all communities, right? It's a foundation of where we, of who we are as a country. You know, we're now looking at increased access rates in terms of electricity. We're now looking at new development in terms of roads, in terms of buildings. And there has been a very huge considered effort from the government in terms of facilitating that. And then if you look at some of the countries that have been able to do it quite well, you know, that has all created not only new jobs, improved quality of life, and also sustainability in terms of the long-term aspiration for a lot of for a lot of societies. However, if you then narrow it down, I think for me with this presentation, I would like to just focus on transportation, energy, water, and waste management. So if we look at what's been happening within the transportation sector, you know, we are talking about the use of AI, you know, to improve traffic flow, reduce congestion, and even increase safety. There's always a joke that, you know, for those that have ever gone to Addis Ababa or Dar es Salaam in up north, where traffic is horrible, you know, where they can possibly use and utilize some of these new AI tools. In London, they're now using IoT, Internet of Things sensors to also do monitoring and identification of people that are speeding. And then also in San Francisco, they're not using self-driving cars. On the renewable energy space, yes, I think you all have been hearing about the energy transition locally. You've all been hearing about the democratization of energy. I'll speak about that later on. But if you look from a global context, you know, there's also the notion of energy efficiency. So just an unvalidated but professional fact would be, if we are to have a day, just an hour, where the entire country switches off their geyser, everyone in the country just switches off their geyser at night, maybe at 6 p.m., we will probably be able to reduce quite a lot of the actual country demand. And part of that basis falls into some of these energy efficient measures, which also look into how to improve energy consumption within houses. And then on the smart water management system, you know, a lot of tools are still being used now. And again, it all rises to collection of data and then using either data validation and data analysis tools, primarily from with AI, to be able to identify patterns in terms of water usage and then also identify leaks, which many times actually saves a lot of money for a lot of the service providers. And then there's also the new one, which is the waste to energy technologies, you know, where people actually use dirty diapers. I do know that there's even a company in Pretoria, Silverton, that is trying to get up with such a technology of collecting baby, toddler diapers, used diapers, and they're using that to generate electricity. It's not a lot of electricity, but because obviously there is the economics of scale that they'll need to consider, but in the long run, that it's the business case is there. And why are we then talking about all of this? I think at its core, when you look at new technologies and innovation, the biggest thing always boils down to data, accessibility of data, how much data you have, within this next revolution that we're entering now, which is the fifth revolution. The whole emphasis is on data, and the reason behind that is that within data, you are able to assess and learn more patterns that will be able for you to come up with proper solutions that can help in the long run. And then besides then the data aspect, if you look at what's now happening, even on the energy side, with the whole conversation of green hydrogen. I think you all have been, if you read the news or listen to the news, there's been conversation about green hydrogen. There's been conversation about nuclear, where it fits in. And the part of the reason behind that is that, yes, as you talk about the transitioning out of the coal-based power into renewable energy plants like solar and wind, you still need to solve the issue of baseload and intermittency, which unfortunately wind and solar would not be able to address. So alternatives would be the green hydrogen. But for green hydrogen, for the process of electrolysis, you would still need something like a wind power plant or a solar plant that can then be able to provide the heat energy source for the electrolysis for you to then be able to ramp up and produce that green hydrogen power. So all of these technologies, which are still new, especially within the context of South Africa, but there is money that's being fed into that space. It's technologies that have an end goal. And again, that end goal is obviously to help within the economy, to help within the development of the communities. And I think another interesting part, especially if you look at green hydrogen, still focusing on the renewable energy aspect, right, is that from a construction perspective, if you look at a solar plant, you're looking at about, depending on the magnitude, so I'm talking about 300 megawatts and above, you're talking at about 3,000 to 5,000 workers that possibly would be needed. But in terms of the maintenance of that plant post-commissioning, it's a few hundred people that would be needed. But then if you look at now the green hydrogen, the conversation almost becomes a little bit different, because you're almost talking about a total replication of the workforce that, in terms of numbers, that would have been used on a coal power plant. So again, this is almost where the whole interest is also arising from, to say, if you are able to retain some of those jobs through this new technology, this emerging technology, then surely then that becomes a viable option. And why is it important? I think, automation and streamlined processes, there's always that whole conversation of improved efficiency. I spoke about the whole GESA story. A lot of you, if on LinkedIn, you should follow Sanedi on LinkedIn or even in Google. They have quite a lot of publications around some of these energy efficiency measures, how, from an energy perspective, but also if you now look at it from a water perspective, the amount of money that, or even water that gets lost in terms of some of these unidentified water lakes from a bulk scale perspective, it's quite huge. And then, yeah, there's the whole reduced environmental impact, because one thing that the emerging technologies are focusing on is on a cleaner and green environment, no matter which sector, no matter whether it's waste management, whether it's transportation with electrical vehicles, whether it's energy, whether it's ICT, there is an element of environmental impact. From an ICT perspective, we used to talk about data storage in terms of actual physical hard drive, but now we're talking about the cloud-based. And all of that brings in that huge advantage. And then why it then becomes quite important, and why we're having conversations like this, and why consulting engineers kind of fit into this bigger picture, because if you look at it from an innovation perspective, a lot of that lies, or there's almost an expectation from a lot of of these consulting engineers who many times provide some of this design. So these innovations are not going to be implemented from a government perspective or from a financial perspective. It's actually engineering companies that have the ability or power to be able to implement these technologies. And I think as you were discussing some of these topics, I think it's also quite important. I think most of you might already be doing that. I know a lot of companies are doing some of this cool, clean tech. Tato mentioned computer vision that's happening on sites. There's not only the benefits discussed, but also there's benefits from a financial point of view, from a business perspective, for some of the companies that are implementing that. And then the challenges. I think it's always great and it's always aspirational to talk about new technologies, to talk about innovation, in the space that we're in now, and especially from the onset of load shedding. Sorry to jump back to energy, is that you get a lot of people that throw buzzwords. People love to use buzzwords, and many times it creates a very negative notion around the embracing of these new technologies, because either it actually doesn't make sense for people, or people are just afraid for change, because obviously they always comes with a huge risk. But I think one of the biggest challenges is obviously lack of funding. And to come back to my original statement that I did about the 2.25 billion rands per day, which was in 2020. So now it's 3 years later. Of that amount, there's another study that was released by the South African Infrastructure Forum that say that 30% of all of these projects across all of those sectors actually end up failing. Either failing or not even meeting their targets, 30%. And that's a lot of money if you kind of work it backwards from an annual perspective. And lack of funding is attributed to 30% of that. And I think in the context of South Africa, I think it's not easy to access funding. And now, speaking from a development point of view, it's not easy to get funding. And part of that obviously has to do with the politics, has to do with the high risk status of the country. But with funding, it's almost a regional perspective. It's almost a regional issue, to also kind of give you guys a bit of context, right? So the immediate solution to load shedding right now would be buying power from countries that are sitting with excess. Angola sits with about 2,500 megawatts of excess energy. However, that energy is being lost because Angola is not connected to the Southern Africa power pool. So Angola does not have networks where it's connected to any country in Southern Africa. So they can't even export that power. What we're trying to now do with that is being to introduce the Angola-Namibia line to be able to facilitate for that. However, that project has been in development for almost, I think, close to 10 years. But it has benefits, but it's just that to access some of that funding, it's a bit difficult. Another example is also Malawi. Malawi sits with a lot of excess hydro and solar energy. Up north, by the border of Malawi, Mozambique, you are sitting with a huge hydro potential from Kawara Basa and another hydrogen power station, which is going to be built, which is called Mpandangoa. However, within Mozambique itself, there is no internal strengthened corridor that can be able to evacuate some of that power down south over to South Africa. And part of that has to do with lack of infrastructure, so lack of transmission infrastructure. And then you come back to South Africa, where you're sitting in Northern Cape with an abundance of energy, renewable energy resources, wind, solar, but there's no infrastructure in terms of transmission that can be able to evacuate that. And part reason, again, going back to the funding perspective. So funding is a huge factor, and unfortunately, it's almost like the biggest barrier here. The other thing is the lack of skilled professionals, right? I think that also always becomes an issue because whilst, yes, it's easy to say, consulting companies should be leading the drive for new innovations and technologies, but, in a consulting engineering space, it's very different from that space where I come from, where, dedicated funding can be put into new R&D work. In consulting, someone has to pay for any of that R&D, and many part of that payment has to come in from some of these projects. And if there's no projects and if there's no funding that's happening in those projects, then most of the consulting companies won't be able to empower or assess their own people in terms of developing them to be able to be leaders within that space also. And I think the biggest one also is data privacy and security concern. I think that's always a big issue. And then interdepartmental coordination. I think one of the other biggest thing is that they lack coordination, information sharing, not only, and this is not even a South African consulting engineers issue. It's a global thing, right? Companies or other stakeholders they don't want to share information. They don't want to share data, and you can't blame them because obviously there's a business reason behind that. But if for some of you guys, whether you work on bridge projects within South Africa or across the region, you might have gotten to a point where your design project where you need reference data, you might have struggled to actually get some of that data because there's a company XYZ that might have done the project previously, but to be able to go to that company and say, hey, can you share some of the data that you can, it's close to impossible. So that deters a lot of the innovation. However, how can those challenges be overcome? I think the first part is about identifying the opportunities. I think throughout this discussion, I mainly focus on the energy side. Nowadays, from the work that we're doing now, we're looking at innovative transmission financing models that can be implemented within the South African context, right? To say if it's becoming difficult for entities like Eskom to access funding from developed financiers, why not look at it from what other countries are doing from a global perspective? So there's this new thing called climate financing, which I do advise a lot of you here that are interested in developing new skills to look into. And it's a big thing because a lot of the big donors and financiers are putting in money under the umbrella of climate financing. And climate financing does not really have to end with transmission project, but also renewable energy projects, but also even infrastructure projects like transport and water. And that's a big thing because ultimately the issue is how can you be able to unlock business cases for some of these projects? And then also developing and implementing plans to incorporate technology and engineering innovation. I think we need to be able to get to the point where we see some of these new innovations as doors to growth within our companies. And then also being risk averse, from an operations point of view. I think this is something that should be widely embraced. And then in conclusion, I think the key takeaway here is that there is opportunities. The technologies are there, maybe not the ones that I didn't mention, but technologies that you all might be aware of or you might all know of. They're there. And if it's not just about the technologies, there's also some innovative frameworks that are being studied or that you guys are reading on. They exist. But I think the next part within this conversation now talks about the implementation part. And I think that becomes quite important because if the donors and the financiers are willing to put in money, the question also comes into where does the consulting engineering community fit in here, and which is why we're having this discussion into what types of technologies and how we can be able to leverage part of this new emerging technologies into what we do. And then I put in some few examples here in terms of what's been happening locally. I think I spoke about the 3D printing. You guys have been reading about it. You guys have all been hearing about drone technology. Tato spoke about fault detection with transmission line, where some of these drones are taking some of the imagery to be able to do fault location. And then you're also looking at artificial intelligence, where some of the municipalities like city of eThekwini is using artificial intelligence in their water distribution systems. These are just some of these examples. And even with the challenges that I've mentioned, I think one thing is quite evident is that the opportunities is there, and the consulting engineering space is well placed to be able to take a leading role in this. Thank you. And if you guys have any questions and further discussions, you can always follow me on LinkedIn or pass me an email. Thanks.
Thank you so much, Keith. What an informative session. Wow, it's eye-opening. I actually didn't realize that over 30% of projects fail, which means billions and billions of rands are misspent if a project fails, and how technology is so important in ensuring that we are able to reduce this number to close to zero as possible. Another thing which I think was quite important from what I took out was quite important is that as we're talking about design, we are now referring to more cleaner energy. We are talking about more environmentally friendly solution, which means our kids and our grandkids, great-grandkids will come to a better world with the better projects. With that, thank you so much, Keith. I know that you will be sharing with us a brief on when you talk about AI water distribution system in Durban. My question would be, you will just need to expand a bit more on what are they doing there, and how can the member firms learn from it and be able to take it to the next level. The reason why I'm asking Keith to answer this particular question is that he will have to leave us at 1 o'clock. So I thought, let me just squeeze in one quick question before we move on to our next speaker. So Keith, if you could just give us a simple rundown on the AI water distribution system that you are talking about at the city of eThekwini, and what can our member firms learn from that, and what technologies can they use to execute their next projects within the water space? Let me hand it back to you, Keith.
Yeah, okay. So I'm not a water engineer, but I'll try to explain this as simple as easy as I understand. So basically, it's all boiled down to the position and installation of different sensors and across the water distribution system, and being able to collect enough data to be able to monitor and maintain the water flows across the different channels. So what this gives an advantage of is being able to do the leakage detections, but also to be able to roll out sort of like planned and predictive monitoring within those systems. But I'm happy to share some of the readings post the session. I'll share them with Godfrey.
Thank you so much. Let me introduce our last speaker for the day. He comes also with a very high pedigree. When I was speaking to him, I could not stop by see that he's got 2 cum laudes, not 1. And I was saying to him, while we were studying, while we were sleeping, he was studying. And his answer was exactly that. He said, study, study, study. So, Steve, excellent work. Your resume is also so powerful. I know that you like athletics and powerlifting, which is quite interesting. And maybe as you introduce yourself a little bit more so that we get to know you, you'll be able to say exactly what about powerlifting is that actually caught your eye. So Steve Rose comes from, he's a Director Advisory Group for Industrial Energy Asset Management at Royal Haskoning, and he will be educating us on leveraging digitalization for improved project performance. I hand over to you, Steve.
Thank you so much. Good day, everybody. Thank you very much to CESA for allowing us the opportunity to present this today. And thank you to the fellow presenters and to all of you on the webinar today. My name is Stephen Rose. I'm a director at Royal Haskoning DHV, looking after the industrial sector for the company. In terms of today, sorry, just with regards to the previous question, the powerlifting thing is a strength sport, and it's quite an interesting sport, just picking heavy stuff up and putting it down again. But it allows you to disconnect from reality for a while. So it's quite attractive to me. So I've really got 3 discussion points today, really simple. What is the case for digitization in construction in the world, in South Africa and in the world? What does digitization look like now as we stand? And what does the future look like? 3 simple questions. But I'd like to open with this first question. What sort of a difference does 100 years make? So if you look at the top picture, top right-hand side, you see a construction site in the 1920s, scaffolding, bricklaying, manual handling of materials. And you look at the picture below that, which is a construction site on a high-rise building, same wooden scaffolding, same wooden formwork, same manual handling. What's really changed? I think construction, beyond the general tools that we use and the safety and the materials of construction to some degree, has not really advanced that much. When I look at both pictures, I see the same picture fundamentally. You still see manual bricklaying, significant amounts of cost in situ solutions, planning tools, supporting infrastructure and supply chains, and piles and piles of construction drawings lying on site. You would think, though, 100 years later, with all our advanced technology, construction projects would be highly efficient operations. I think, though, the data points to the contrary. It's not the case. Large construction projects take, on average, 20% longer to finish than expected, and we're seeing cost increases of up to 80%. This is all reported in a 2016 sector report by McKinsey. The same reports also, however, demonstrated that labor productivity is standing still. As the construction industry advances, we're not seeing more productivity out of our labor. Labor productivity is also not keeping pace with GDP growth. And when you couple those factors with increasing costs of raw materials and worsening margins for contractors, isn't there a case, perhaps, to evaluate a different way of doing things in the construction industry? I think there is. So when surveying the industry, the construction industry, what does it say about digitization? In a survey conducted by IDC in partnership with Autodesk, hundreds of construction firms were analyzed regarding their attitudes on digital transformation. A key finding in this research is that 72% of the contractors said that digital transformation was an absolute priority for them, major priority. But, and this is a big but, about 1/3 said that they invest less than 3% of their turnover in digital technologies and tooling. This demonstrates that the intention is there, but as we all know, you can't bake a cake without an oven. A worrying statistic from this survey is that about 1/3 of the construction firms surveyed as well class themselves as digital resistors, implying that they actively avoided and resisted the digital transformation movement. So much so that 11% of the firms surveyed go so far as to say that they declined to bid when BIM is specified in the project requirements. The question could and should be asked then, why still the resistance? Well, it's quite simple. It's time and money. Construction is a difficult business, let's be honest. Beset by technical challenges, volatility in the market, uncertainty, and extreme competitiveness. So why would you invest time and money into something that will likely only bring rewards in a few years? The answer to that is really twofold. The same McKinsey report suggests that a digital transformation directly yields immediate cost reductions of between 4 and 6%. And additionally, indirect labor efficiencies rise by up to 50%. That's huge. That's a huge, huge, huge thing. So that's what the statistics say. It's also good to understand where the construction industry is at the moment. From the figure on the right-hand side, you can see that the construction industry is the second lowest ranked in terms of digital transformation, only above agriculture and hunting. I think another worrying statistic is that on average, under 1% is spent in the construction industry on R&D. And you compare that to 3.5 to 4.5 in the automotive and aerospace sectors. Now, this is incredibly worrying because we know that industry is transforming into industry 4.0. Will we ever see a construction 4.0 industry or even 3.0? I find it worrying. I think the primary difficulties here are in finding a solution that fits the varying nature of construction and then scaling that solution. That is where the complexity lies. You look at some more of the pros and cons associated with digital transformation for the construction industry. You look at the help of new process structures, planning and construction, with the help of new processing structures and more digital structures. Planning and construction projects can be made more transparent, more reliable, and less prone to errors. Software that creates a digital twin of a real building is used for this purpose. Stakeholders use these models to record and manage data and see building changes in real time. That's a real positive. Digital models help reduce environmental footprints. That's absolutely true. Designs can be quickly calculated, changed, specified, respecified, modeled to determine how best they fit their environment and how best they can contribute to sustainability. Cloud solutions are also suitable for agile, efficient collaboration in projects. That's why they allow faster and more transparent communication. The rewards are clear, right? We just saw the McKinsey report suggests 4 to 6% cost reduction. That immediately goes down to the margin. Additionally, automating and digitizing certain tasks increases the level of repeatability and control, therefore increasing the level of quality delivered. Now we look at some of the arguments against. The skills and specialisms that are required to make this transition are rare. That's not to mention even that the majority of the workforce on a construction site are not suitably qualified. So this necessitates an investment into training. While you're investing in training, you need to invest in software, systems, hardware, etc. This may be extremely difficult or even prohibitive for small companies. The resistance to change is also a major hurdle as well. And this is evident in industry surveys, as we saw previously. The question, the adage, if it ain't broke, why fix it, is true. You know, construction is working. Why would you want to change? Another key point, another key con so far is that there's a lack of standardization at the moment. Beyond the standardization brought in by ISO 19650, the rest is really anybody's game. So it leads to a situation where there's resistance to investment, because what if you invest in the wrong technology at the time and something else becomes the chosen solution or the scaled solution? Perhaps the industry is waiting until appropriate standards are introduced to support and safeguard the investment. So then, if you look at where digitization is now in the industry, in the construction industry, you see digitization like this. I don't believe that digitization only means that robots laying bricks and AI doing design. In some cases, that is the case, though. But in the vast majority of the digital transformation, answer is no. Digitization is the coming together of digital tooling, automation, communication, data harvesting, and the use thereof to deliver projects at efficiency rates far beyond what is currently achievable. What's interesting is that it's not just one single piece of technology or software or hardware that's driving the change in the industry. It's the confluence of all the advancements made incrementally that's pushing the digitization transformation in construction. So we've effectively got 6 main silos at the moment that advancement is working in. It's BIM, it's IoT, which is Internet of Things, AI, 3D printing, robotics, and drones. And of course, the field is vast, so there's significantly more tools and things like computer vision that we discussed earlier, but this is just a broad characterization. So if we look at BIM, for instance, BIM is building information modeling. And to quote Autodesk directly, BIM is the holistic process of creating and managing information for a built asset. Based on an intelligent model enabled by a cloud platform, BIM integrates structured, multidisciplinary data to produce a digital representation of an asset across its life cycle, from planning and design to construction and operations. I should also include closeout to that, actually. With regards to BIM, this is probably the most widely used of the digital tools at the moment. Its usage statistics are climbing dramatically as well, according primarily to Autodesk, who provide one of the leading software platforms in this case. 60% of architects currently use BIM technology. That's a huge number. 51% of MEP and structural engineers use BIM, 46% of civil engineers, and only 41% of contractors. Now, those statistics are currently what's in the market, but what Autodesk also reports is that the statistics and the usage is climbing incrementally every year. The annual growth rate is measurable and meaningful. So in a couple of years, it'll be the standard. Now, what's important to understand about BIM is that it's about information. It's not pretty drawings, right? It is pretty drawings as well, but it's primarily about information. The information itself is the information that is stored in the physical asset. For instance, when we design a facility in Revit, we parameterize each asset within the model with information. A light switch, for instance, would include a manufacturer's name, the type of switch it is, which DB it's fed from, etc. This makes the design process not only easier, but also when transitioned to operations and constructions, it paves the way for 4D, 5D, 6D, and ultimately 7D planning. And those are dimensions as annotated. Now, it's important to understand the dimensions of the BIM environment. 4D planning is all about time. When you talk about a digital 4D model, that's a time model included with the 3 spatial dimensions. When you add time or a schedule characteristic, this allows you to see the sequence in which the build will occur. Now, you can imagine how helpful this would be when considering constructability or forward planning for a contractor. 5D includes money. So now you've got the 3 spatial dimensions, time and money. So how you parameterize money is that each element of the Revit model is parameterized. You could assign a capital value to it or an installation value, and you could physically visualize your cash flow down to nut and bolt, brick by brick, beam by beam, building by building, facility by facility. This is incredibly useful when you look at optimization or value engineering, as it allows you to quickly run scenarios and get immediate answers. If I change this facade from a brick facade to a panel facade, would it be cheaper? Well, it's as simple as deleting this element and placing another element, looking at the overall cost in the 5D model. There's my answer. When we include 6D planning, that is now where sustainability comes in. And 6D planning is interesting because it now includes things like energy characteristics, heat flow characteristics. Then you can start playing with which is the optimal design for the building from a sustainability perspective, which allows you the highest LEED certification, which allows you to use the least amount of energy in heating and cooling. It's something that I believe will soon become the norm and requirement. 7D planning is the final step. It's where the model itself becomes an operational model, or where it's used by facilities management. So remember that light switch that I spoke about? That would have an O&M manual. Or for instance, say there was a light bulb. The light bulb would have all of its data inputted, and there would be an O&M manual, and there would also be, intention is of course, in the digital transformation, for the facilities manager to go in, look at the light bulb is out, okay, I can press a button and it sends a push request to supply chain to buy a new light bulb, or to maintenance to install a new light bulb, however it might be. What governs the use of BIM is the ISO 19650 standard, which is a relatively new standard. But it's described as the international standard for managing information over the whole life cycle of a built asset using BIM. The next of the digital transformation tools currently being used is IoT. IoT in construction is a really cool topic. I quite like it a lot. But the applications here are literally endless. But when viewed effectively, it involves using a device or a system that is able to communicate with another to form an ecosystem of connected components that together becomes a more intelligent system. A reasonably new application that I read about the other day is using temperature probes embedded in concrete to estimate how far the concrete is in the curing process. This allows the contractor or the engineer to determine if the concrete is curing at the correct rate. And if, for instance, it's curing at a faster rate than usual, one could then speed up the construction process. You could also imagine putting strain gauges on temporary works that are connected to a safety system that monitors whether the temporary works are performing as they should or if they're overloaded. Something that is also now quite common is using RFID or barcodes on materials of construction to automate the stock holding process. So a steel beam, for instance, is given a barcode or an RFID tag. It's tagged in when it comes into stock, and when it is used on site, it's tagged out. So that allows your stock holding process to be managed automatically. So when you reach the certain low level, it automatically sends a request to the supplier to deliver more beams. And this can go throughout the entire value chain. This brings forward the possibility of just-in-time scheduling, which is extremely important on highly constrained sites where storage is a premium. Another application is vehicle tracking. Vehicle tracking has been around for quite a bit, especially in mining. In construction, however, you could use this and you could go one step further and install onboard diagnostics connected to a central hub to monitor performance and efficiency of construction vehicles, reducing downtime, ensuring performance is optimized, reducing emissions. Vehicles can be switched off or used for a lesser amount of time, and really as well, monitoring safety of individuals. Augmented reality, computer vision, as spoke about earlier, is also an excellent construction tool that, when used correctly, becomes invaluable in construction. The teams that I lead use augmented reality on our sites. They use iPads that are fitted with cameras and LiDAR. I think it's LiDAR. Yes, it's LiDAR, that overlay the BIM model with a real-time camera footage to visualize the final build. You can physically move the iPad around on site and check and count the rebar against the design, ensure that penetrations through the walls are in the right place, check pipe clearances and electrical containment, all while walking around on a Teams meeting. It's quite amazing. The next one, however, an important thing to note about IoT is that while the investment costs are substantial, the payoff lies within the efficiency afforded. AI, an interesting one as well. Currently in its infancy, and also quite a popular term. We think ChatGPT when you think AI. I'm not sure about you, but that's what I think. In construction, its applications are quite varied and may prove to be quite useful in the future. An interesting use case is presented as the holistic optimization of parameters, such as construction costs, location, client requirements, building limitations, etc. Where you take all of those parameters and put them into a model, and the software generates a best fit solution for the chosen asset on the site that it is. I've seen the beginnings of this in the optimization of building structural frames on a high-rise in Europe. Another use case is project planning using autonomous vehicles, doing scans of building sites at regular periods. That's quite an interesting one. You send a little autonomous vehicle out, it scans the facility with a point cloud scanner, and those scans are interpreted by the AI software, and using computer vision and object recognition, back calculate the progress of each element and sub-element of the build, allowing even small slippages in the schedule to be identified at a very early stage. Another concept is big data. Now, imagine for the future a ChatGPT type tool which has access to thousands of projects around the world. One could ask the AI, what is the optimal characteristics for a wastewater treatment plant in Timbuktu to minimize construction duration with a mid-tier contractor? Put it into the software and it would come up with an answer. That's potentially the future. Another one that we've all seen, I'm sure if you've browsed LinkedIn in the past, you've seen the 3D houses being built with the 3D printers spewing out concrete. I think we've all seen the videos, but it's an interesting application, but not yet practical for large scale construction. I think beyond the simple family houses that we've all seen, China has completed a demonstration apartment block in the Jiangsu province in 2015, and Dubai completed a 640 square meter admin building in 2020. At the moment, the technology is in the exploratory stage, but one could imagine a future where simplex structures such as low-cost housing are printed in their thousands in a highly repetitive, cost-efficient, and high-quality way. That's where I believe the future is for 3D printing in construction. Robotics is an incredibly interesting one as well. I think the applications for robotics in Industry 4.0 are well established and highly successful. Automated assembly, welding, and painting lines are common across vehicle manufacturing plants around the world. In construction, however, the uptake has been slower. And I believe this is due to the variability and uniqueness of each construction site. You may not have realized it, however. In some cases, robots have been on construction sites for quite a while. What you see is robotic welders and remote controlled demolition units that are available, like the picture that you see in the top there. The remote controlled demolition units are being used throughout Europe at the moment as a way to improve worker safety. Some applications that are nearing commercial use, so not yet in commercial use, are automated or semi-automated bricklaying robots, automated layout and measuring robots, automated hauling units, such as Spot, as you see on the bottom of the screen, self-driving trucks and vehicles, automated monitoring vehicles with cameras and laser equipment, scanning equipment. And additionally, something that I found incredibly interesting was rebar installation robots. I mean, the possibilities are endless, right? It's up to your imagination. For me personally, I don't see a world in which construction sites are completely autonomous. The most likely optimal point where would be highly skilled workers working alongside their robot counterparts to augment their abilities. Robots would do the heavy lifting, boost productivity, and keep sites safer by the elimination of generally high-risk tasks, and humans would provide that eye for construction, that final level of quality control, the point-and-shoot nature of construction as well. Regarding drones, I think drones, we're all familiar with drones, but drone usage as a digital transition is seeing massive growth, 239% cumulative annual growth rate per year in the use of drone technology in construction. They're exceptionally useful little flying machines and offer the user real-time data capturing. They also offer unique vantage points and the potential to drastically increase the accuracy of construction while simultaneously improving the safety of people on the site. One of the most significant uses is topographic mapping and land surveys. Drone mapping is hugely faster and approximately 20 times less in cost than regular mapping. Another interesting use, of course, is remote monitoring, which is used in the surveying space, where contractors' tonnages, particularly in mining, are measured using LiDAR equipment that is drone mounted, bringing the accuracy of payment certificates to a whole new level. I can see this application working quite well in the roads and bulk transportation infrastructure sectors. Security and surveillance is potentially another application. as well as the use of drones for structural and systems inspections. Thermal sensors mounted to drones can be used to evaluate hot or cold spots, leakages on pipelines, for instance, or bulk storage vessels, as well as, like the presenter before me mentioned, hotspots on electrical systems, indicating installation failures or the potential for imminent failure. So that's what it looks like now. The question is, what does the future look like? So I think the future is quite interesting, and an author by the name of Wyman provided an excellent infographic, which is repeated here, where construction is broken down into digital construction in the future is broken down into three primary silos. That's work processes, machines, equipment, and workers, and industrialized models. Now, we've spoken a bit about interactive work processes, such as the use of visualization and simulation, which is the use of augmented reality, computer vision. We haven't spoken about dematerialized and reactive workflows, which is really the connection of all the workflows via the Internet of Things, via the use of sensors and equipment, drones, all of those sort of things to provide a network of information about the construction site. Now, connected machine equipment and workers as well is the acceleration of the digital transition. It involves the use of automation for surveys, scanning, mapping. For instance, you would have a quantity, where now we would have a quantity surveyor on site. In the future, you'd have a drone doing the measurements every day autonomously and reporting on progress, performance, inventory. You'd also have drones monitoring safety as well. Connected workforce and tools. You could imagine in the future a worker being fitted with an exoskeleton, a skeleton that sits outside of the body that allows the worker to lift 10 times what he can now or she can now. You'd also imagine a world in which inventory and tools management is completely autonomous. So you can track and you know exactly where your excavator is now. You know what it's doing. You know how well it's performing. In the future as well, energy is a premium for us. So energy consumption and optimization is something that needs to be corrected and needs to be monitored and evaluated in the future. Machine performance optimization. We know full well that you can't have machines running on diesel on idle because that is not only bad for the environment, but it's bad for productivity. You could imagine machines being monitored centrally through a construction hub where they're simply turned off or failures are recognized and corrected early. Machine performance as well, optimization that goes hand in hand. Automation, of course, we spoke about the rebar robots earlier. That's something that's coming to the future. Imagine tying off 1,000 square meters of rebar, whereas you could get a robot to do the same. Then we move into the industrialized models of construction. Now we consider cost in situ solutions for buildings and for industrial structures, but the future really is the development of factories of factories. So these are factories producing modular equipment that then gets assembled on site, plugged and played to become its own little factory. That is the industrialization of processes into parts, factories of factories. I think something interesting as well is we spoke about the digital twin, which is what I'll conclude with. And the digital twin is interesting because the future of the construction industry is inherently tied to the digital twin. The digital twin itself is primarily the marrying of cyber-physical data and information exchange, where a replica of a physical asset is created in a digital space. In digital twin technology, we have 5 levels of development. As applied to construction, level 1 is the descriptive twin, is a visual replica of a live editable design. It's what we all understand at the moment as BIM and Revit models, etc. Level 2 is the informative twin, which uses increased integration with sensors and operations to give data. Level 3 is where things start to become interesting. This is the predictive twin. This uses real-time data and analytics to identify potential issues. Here, one could imagine the robot running around the construction site, scanning the progress on site and reporting that we're starting to slip in certain areas. Level 4 is where the digital twin becomes a predictive tool. Comprehensive twin leverages advanced modeling and simulation for potential future scenarios, as well as prescriptive analytics, and uses the simulations it provides to provide recommendations. Level 5, which I think we're at least a few years away from, is where it becomes autonomous, the factory of factories, where it's a control panel and the operator presses a button and the factory starts building it, using its own tooling, its own sensors, its own systems to pull what it needs from inventory, order what it needs from another factory, direct workers or robots to do whatever it needs to build the structures that it has to build. I think I'm running out of time. I think I've just run out of time, actually, hence I had to shorten the last one a little bit, but that's the end of it from me. I've reached my time limit now. So thank you very much for your time today, and I look forward to any questions, or reach out to me directly if you have any.
Thank you so much, Steve. What an amazing presentation. You know, one of the things that I've taken away, and I'm going to use this as my next quote. You can't bake a cake without an oven. So that was amazing. And the reason being is that as we discuss this technology, we must be cognizant that we need the technology for improvement. We can't improve without technology. We just can't. And you've made it such an easy way of looking at it. I mean, you've touched on several things. You know, how can a construction industry be close to an agricultural manual labor industry? It's impossible. You know, our engineers must now start seeing the value in including technology in their solutions. Right. Another important thing that I think that we must touch on is, with this digitalization, we are now going to have highly skilled few individuals working, not like before. So it's not going to be a lot of individuals. It's going to be highly skilled. And I urge member firms and people who are visiting and watching that, get yourself skilled in digitalization, because it's the next thing. It's moving that way. As you become highly skilled, you become highly valuable. The digital twin, in its all stages, have shown that that is where we are going. With that, Steve, thank you so much for your presentation. What I'm going to ask now is, are there any questions for our panelists, Steve and Tato? If you could raise either your hand or you jot it down on the question and answer, we will then be able to answer any questions. If there are no questions, we will then close off the meeting or the webinar. And another thing I just want to apologize is that we have gone over our allocated time. So if there's no questions, are there any questions? Can I ask Blessing, have you spotted any questions on the chat?
I think the only question was regarding the CPD. There was one question saying, is this webinar carrying any CPD credits? And the answer to that is yes. So there's 0.15 CPD credit allocated to this webinar.
Right. Thank you so much. And if you can just explain, how do we get the CPD points? Is it through the registration that we had completed?
Yes. So if you have registered, and besides, if because I mean, there will be an attendance register that we're going to derive from Zoom, and you can request normally we send what we call the attendance certificate or the acknowledgement, and that acknowledgement will have the CPD validation number on it. If it's not forthcoming, you're most welcome to contact our offices requesting for such.
All right. With that, I would like to say thank you so much to our panelists. Thank you to CESA for allowing me to be able to facilitate such a wonderful topic on digitalization. And also I'd like to thank Godfrey and his team for working around the clock, not forgetting Debbie, who's been such a wonderful help in ensuring that we get this thing up and running. With that, I would like to say thank you and cheers to everyone.